This video will be a brief summary of Colonel John Boyd's career and ideas and how they could apply to current issues in process automation. At the end, recommendations will be made for future process automation improvements. Colonel Boyd has been called the most significant military figure that no one has ever heard of. I'm sure most of you watching this video have not heard of Colonel Boyd. This video will attempt to summarize and cover 2 hours of material in 10 slides. For the purposes of comparison, consider the plant's operators as fighter pilots, consider the DCS as a fighter jet, consider the running of a chemical production line the same as air-to-air combat, and consider process automation professionals as test pilots. The way I see it, manufacturing in America has 6 main challenges. These are increased safety expectations, increased quality expectations, workforce turnover with a 24-hour operation, baby boom retirement, economic pressure from competitors in the global economy, and the ongoing rise in obsolete I/O in American manufacturing plants. Boyd faced similar challenges in his career. The next slides will summarize these challenges and will briefly address how he took these challenges on. Boyd's career spanned from the end of the Korean War to the First Gulf War. During this time period between 1952 and 1992, the jet replaced the piston planes and was continuously improved, culminating with the F-15 and F-16. Offset by 30 years is the rise of process automation. During the time period between 1982 and 2012, the modern DCS replaced panel boards and early PLC control and was continuously improved to the modern integrated DCSs like Delta V and Rockwell's PAX systems. The 21st century jet today is the F-35, the most advanced and expensive fighter jet in history. Yet this came at a cost. The F-35 has poorer dogfighting capabilities than the lower-tech, lower-cost F-16. The F-35's advantage is beyond the visual range attack that avoids dogfighting. What will the 21st century process automation look like? Will it be a complex and expensive DCS like the F-35? Will the 21st century process automation be so focused on preventive measures that there is little for the operator to react to? But if the advanced capabilities fail, will a 21st century DCS be more difficult for the operator to use to control the process than the existing DCSs? Let's look at some of the early challenges Boyd faced during his career and analogies to process automation. 1950 to 1970 saw the challenge of replacing the large volume of retiring World War II pilots. Today, we have the challenge of replacing the large volume of retiring baby boom operators. The pilots up to the 1960s were largely trained via on-the-job training, OJT. Most didn't learn combat skills until a war broke out. Those who survived became good pilots and maybe even aces. Are we still primarily training our new operators via OJT? After the basics of flying, training was focused on bombing, not dogfighting. After basic skills of sample taking and commanding I/O devices, what kind of specialized training are the operators given? Is there training in troubleshooting equipment? Is there training in working through alarm flood situations? The MiG-15 was superior to the F-86 by all of the traditional comparison measurements. Are we finding that our DCS system is inferior to those used by our competitors? This may call for an upgrade, but maybe not. The F-86 had a 10-to-1 kill ratio over the MiG-15. An inferior DCS system may have opportunities to perform better than a new DCS. McNamara's insistence on multi-role jets led to the F-4 and F-111, which were even more inferior to Soviet fighters than the F-86. Are the vertically integrated advanced DCSs delivering better value than the DCS they replaced? Are they delivering better value than a collection of single-role process automation systems from multiple vendors? Boyd's early challenges stemmed from Army Air Corps and later the Air Force's doctrine that favored bombers over fighters. Is senior management focused on priorities other than automation? If yes, then the long-term viability of the company manufacturing goods in America is in jeopardy. Let's look at some of the later challenges Boyd faced during his career and analogies to process automation. In the post-Vietnam 1970s, there were big budget cuts. New weapon systems competed for fewer resources. Are we facing financial pressure today from the global economy to keep manufacturing low, yet still improve safety and quality? The Pentagon spending policies promoted waste. When money was available in the 1980s, the wasteful spending got worse. How are the spending policies at your company? Have there been accounting irregularities? Have projects been installed in the plant that haven't worked? Have projects ran over budget? Have pet projects been prioritized over essential projects? The poor performance of the F-4 and F-111 spawned the desire for a new fighter jet. Yet, there were inadequate standards for defining what specifications would be required to create a fighter that would be superior to every other fighter in the world. The previous four wars, World War I, World War II, Korean, and Vietnam, all began with the United States having the inferior fighter plane. If the decision has been made to upgrade the DCS to a new system, are there adequate standards for selecting the new DCS? Are there adequate standards for selecting new IO families, coding protocols, and HMI design? Are the problems in the Pentagon unique in America? Many plants have older automation equipment that has reached the end of life. Are new purchases done with a sharp eye on quality, cost, safety, and performance? Are process automation projects focused solely on deployment with little concern over cost, quality, performance, or safety? Boyd's solutions to these challenges look simple now, but they were revolutionary at the time. Boyd's aerial attack study documented every possible dogfighting combat tactic. It turned the art of dogfighting into a science. A new pilot could study every possible maneuver for each situation before the start of a new war. Boyd's book is still considered the worldwide standard for combat fighter pilot tactics today, 60 years after it had been written. Is there an equivalent for operators? Has running the plant been turned into a science? Running the plant would include troubleshooting equipment, managing alarm flood situations, and managing multiple production lines, along with the prioritization of the multiple rapid-fire decisions coming from them. Boyd's energy maneuverability theory, EMT, became the new standard for fighter jet design. It turned aerial combat into a mathematical equation of energy gain and energy loss. The fighter jet that loses energy the fastest will always lose. Is there a way of measuring the performance of a DCS and helping to troubleshoot equipment, in helping to resolve or avoid alarm flood situations, and in helping to manage multiple production lines? The OODA loop was the theory behind the aerial attack study and has been applied to help explain success and failure of the armies in the major battles of history. OODA is short for Observe, Orient, Decide, and Act. It is a basic decision circle similar to many others pitched to companies by various business consultants. Can OODA be applied to DCS design and operator training? If Boyd were alive today, he would say yes. Boyd was a major player in what became the Pentagon reform movement, which focused on trying to stop wasteful spending. The tactics used by the reform movement could be easily applied to corporate America. Boyd's maneuver warfare was OODA applied to armies. It was adopted by the Marine Corps. The Marines have always been America's elite fighting force, and they have a history of innovation in combat tactics. For process automation, Maneuver warfare could be UDA applied to upgrading obsolete I/O at various plants, and could be applied towards getting operations, HR, IT, maintenance, and engineering to support process automation efforts. Boyd's failures can also have relevance to process automation. Boyd never could alter the Air Force leadership's focus on bombers over fighters. All fighters still have to be able to carry out bombing missions, even if this extra capability reduces aerial combat capabilities. If senior management is not focused on process automation, this should be the first battle and a continuous battle. The role of the DCS is to help the operators run the plant. Extra roles, like interfacing with the ERP and supporting predictive maintenance, should be secondary considerations. The Army couldn't give up the concept of synchronicity, which maneuver warfare called for. Synchronicity caused the failure of the Army to encircle Saddam's Republican Guard troops and trap them in Kuwait, which ultimately triggered a second Gulf War. To be successful in implementing Boyd's ideas, we cannot allow senior management to retain the concept of synchronicity. Automation innovation needs to be moved forward as fast as possible and not wait for HR or engineering or maintenance or IT to approve and support. Boyd would favor using UDA methodology for configuring the DCS to best support the operators. The simplified UDA loop starts with observe. Scan the environment to see from which direction the MiG is coming from and how fast. Then, orient. Based on the observation of the MiG and the F-86 direction and speed, capabilities of the MiG and F-86, and weather conditions, what would be some of the possible countermoves? Then, decide. Pick the best countermove based on pilot experience and training. Then, act. Execute the countermove as quickly as possible. Then the cycle would repeat itself as the pilot will observe the MiG's pilot's reaction to the pilot's countermove and then begin to postulate new countermoves. The successful pilot will cycle through the UDA loop faster than the opponent, such that the MiG will continuously move towards a graver situation and either get shot down or break off the attack and flee. In Boyd's examination of why the inferior F-86 still defeated the MiG-15, he looked at the F-86's bubble canopy and the hydraulic assist of the F-86's control surfaces. The better visibility of the bubble canopy allowed the pilot to see the enemy faster compared to the MiG's canopy, which was characterized as looking through a Coke bottle. Seeing the problem easily and quickly is part of the high-performance HMI graphic standard. Everything is gray except for a problem, which will have the only color. Good alarm management is another important piece that ensures the problem does not become lost in a cloud of nuisance alarms. Trends are more like radar and can spot some problems before they become visible. The heads-up display of modern jet fighters also helps the observe part of UDA. The query display is both a list of brief messages from all of the automation sequences where decisions are required, and a list of some critical alarms that affect sequence decisions. Like the heads-up display, all key information for running all of the equipment is in front of the operator's eyes on one screen. In the Korean War, greater experience and aptitude helped American pilots process through the orient part of UDA faster. Boyd's aerial attack study also helps by giving additional information for possible countermoves. For process automation, formal training and things like managing alarm flood situations can help operators move through the orient part of UDA faster and resolve each alarm quicker. The hydraulic assist of the control surfaces of the F-86 allowed the F-86 to change directions faster. Think of a stopped vehicle and how much easier it is to turn the wheel of a car with power steering versus one without. For process automation, having fully automated sequencing is equivalent to hydraulic assist. If the solution for a response to an alarm flood situation is to shut down a bunch of equipment, it is faster to initiate 2 or 3 shutdown sequences rather than to hand stop all of the necessary motors and hand close all of the necessary valves of the equipment. Once the sequences have been triggered, the operator can go back to observe and look for the next alarm to respond to. Boyd's career can give some insights into DCS replacement. The Air Force was not happy with the F-4's air-to-air combat performance in Vietnam. The addition of a cannon made it easier for the ACT part of UDA and improved performance during dogfighting. Can additional UDA features be added to the existing DCS? Are operators still toggling manual valves as part of normal equipment operation? Can more state-based sequencing be added? If the DCS is to be replaced, avoid the procurement pitfalls that the Pentagon has made. The new A-12 was proposed to replace the A-6. Early cost overrun predictions were ignored. There was no independent auditor. There was the promise of sexy stealth technology that allowed problems to be downplayed. The project was approved without a prototype. If the company is to upgrade to a new DCS, make sure the project proposal has no errors. Make sure that a third party can audit the project. Beware of the promise of sexy technology like APC. Make a plant a prototype. If any pitfalls come up, stop and reevaluate whether it is worth continuing or worth going back and repeating the DCS selection process. The A-12 was a billion-dollar disaster for the Navy. Upgrading to the wrong DCS could be a billion-dollar disaster for a company. All projects need to be data-driven. The ultimate measure of success for a fighter jet is aerial combat victories or kills. These can be measured against the cost of flying the jet on each combat mission or sortie. The F-15 can be deemed a success in that even though it costs twice as much to maintain, it's 35 times more effective in shooting down enemy planes. For a DCS, the measure of effectiveness will depend on how much production can be made per head count of operators. The software and hardware maintenance costs can be higher with the new DCS as long as more production can be gotten out with fewer operators. Boyd argued against the multi-purpose planes like the F-111. Boyd argued for a dedicated air superiority fighter. His acolytes argued for a dedicated ground attack plane. This ended up with the F-16 and A-10. The trend today is that of the multi-role, vertically integrated DCS, much like the F-111. The F-111 was cheered because it could do everything, but it was jeered because it could do nothing very well. The key is whether the extra roles like simulation, APC, and asset management would take away from its primary focus of supporting the operator. These systems typically employ their proprietary I/O that is incompatible with all other DCS systems, thus locking the plant and ultimately the company into a single vendor for future innovation. The alternative would be a single-purpose DCS dedicated to running the plant with an open system that integrates I/O from different vendors and allows for layered software from other vendors for other functions. A world-class asset maintenance software could be layered on top from a different vendor. The same with simulation and APC. I/O could be from multiple vendors depending on cost and performance. In some cases, different DCS systems could be employed within the same plant to optimize the capabilities of a DCS with the needs of each part of the plant's process. The primary goal of any DCS system should be to double the productivity of the operators. A goal is typically a 5 to 10 year activity. To keep manufacturing in America,
we need to have the most productive workforce. The existing DCS should be upgraded by the vendor to allow this to happen. If the vendor falls behind, it will be time to make a change. To accomplish this goal, a new group would need to be created in the organizational chart of a company. Traditionally, process automation has been the ugly stepchild of maintenance, engineering, or IT, as the automation professional has had to have a blend of those three skills. Under maintenance, power distribution systems and electrical infrastructure took priority. Under engineering, installing new production lines and evaluating new catalysts or enzymes took priority. Under IT, the network infrastructure and computer security took priority. Reporting to operations is not a solution. Operations is focused on maintaining headcount, as more people equals more responsibility, which equals more compensation. The operations division is not typically experienced as to the capabilities of automation or the opportunities that automation can create. The future of operations will lie more in scheduling and process technical excellence. The operator's role and skills will be upgraded. A new Top Gun operator position will have to be developed. This Top Gun operator will be focused solely on making the plant run as efficiently as possible by maximizing the capabilities of a DCS. This will be done by consulting on operator training and by picking up many of the day-to-day programming responsibilities currently done by automation programmers today. The automation programmers will function more like a jet test pilot. They will be doing less day-to-day programming and be more focused on testing new automation technologies. This could be new DCS systems, new I/O families, or new third-party software like APC. To feed the Top Gun school, the new Process Automation Division will need to have the sole say in staffing. We need to recruit people who can master automation technology. The days of having HR fill the plant up as if they were staffing a steel mill in the 1960s are over. Manufacturing plants don't need hard workers, they need smart workers. OODA will be the governing ideology of this new process automation division. Sequence code, graphics on the computer displays, and alarm management will all be driven by OODA. Operators will undergo extensive training in automation and will assume much more responsibility of the day-to-day automation activities. As their skill goes up, their pay will go up, and the number of operators needed to run the plant will go down. The metric of production per operator will be tracked and measured and will guide future automation decisions. The new Process Automation Division will optimize the hardware expense. As stated earlier, competitive bidding will play a key role. New technologies will be continuously evaluated. Obsolete I/O will be addressed as a priority and not have to wait behind other priorities of the Operations Division. The Process Automation Division will create and support a Top Gun training school. An operator who graduates from this school will be qualified to fill positions in any plant. The graduates will be day shift only positions. In fact, the plants will be run with a skeleton crew on nights and weekends. The model from the 1970s of rotating positions such that there is the same staffing at night as day will be eliminated. Boyd asserted that machines don't fight wars, people do, and they use their minds. The Top Gun school will be the source of value creation for the division. The skill levels of the staff will drive future hardware purchases as well as drive operating cost efficiencies. Boyd focused on pilot training first and then designed jets to complement the pilot. The Process Automation Division will be focused on operator training. All other software and hardware automation activities will be designed to complement the operator.
This concludes a brief summary of Boyd's work and how it could be used to improve automation and ultimately profitability in American manufacturing plants. The United States is considered to have the best pilots in the world. This was not from OJT, but rather from comprehensive training both in combat tactics and in the capabilities of the jets. The same challenges are facing manufacturing in America some 30 years later. Are manufacturing companies going to invest in the same comprehensive training of operators as the Air Force did? Are we going to develop automation hardware and software that will increase the productivity of manufacturing in America even beyond what we have today? Those companies that do will be in business 50 years from now. Those that don't will either have to relocate their plants overseas to stay in business or sell off the plants to another company that will. Is operations, engineering, IT, maintenance, and HR still going to be allowed veto power over automation decisions? Will manufacturing companies bring process automation out of the shadows and into the spotlight of senior management? As companies face the challenge of manufacturing in a global economy, some will face their Vietnam. The planes of Vietnam were inferior to the enemy's. The tactics of the Army and Marines were inferior. Boyd solved both issues. As companies examine the viability of continuing to manufacture in America, they may want to study the ideas of Boyd and how those ideas could be applied to process automation. Colonel Boyd has been called the most significant military figure that no one has ever heard of. Could Boyd also be the most significant figure in process automation that no one has ever heard of? I'm John Hauge, and I thank you for watching.